Hey guys, so going to cover two more properties of waves in this video. We're going to try to keep it short, but just a reminder, we've covered two properties already. The first one was superposition, and superposition is when two waves run into each other, then we add their amplitudes together. If they're on the same side of our kind of central axis, then they add together and we get constructive interference. And if they're on opposite sides, then when they add together, they actually cancel each other out, kind of like a positive and a negative, and they cancel each other out, giving us destructive interference. So superposition was one property. We talked about diffraction in a previous video as well, and you learned about the tendency of waves to spread out as they travel, which is a good thing. We're also now going to talk about two other properties. One of them is reflection. Now, this you're already very aware of. You've heard, for example, an echo before. An echo works because the sound wave travels, it bounces off the surface, and it comes back. You've seen this with the slinky, right? I would send a pulse down the slinky, it would go down and it would bounce off and it would come back. Okay, so we've had various situations where we've seen the reflection of waves. That's a property of waves. They reflect, they bounce off surfaces. Now, depending on the surface and how smooth it is and lots of other properties, that could determine how much of it reflects and how much of it gets absorbed. But most waves, all waves, reflect in some way, shape, or form, right? Our last property is refraction. Don't get this confused with diffraction. They both are very kind of similar in nature, but remember, diffraction is just the spreading out of the wave. Refraction happens when you change the medium, okay? When you change what the wave is traveling through. And refraction, the principle of refraction says that waves travel different speeds in different mediums. And by different mediums, that means you could take, for example, still air and you change its temperature. Now it's a different medium because wave is going to travel at a different speed, like we've talked about before. So refraction happens when you go from one medium to another. Now it happens right at the surface. Okay, it happens at the location where you change from one medium to the other. Now, a classic example of this is with light, and we'll talk more about light being a wave later, but I take my stick and I put it into my glass here, and you can see, you've seen this before, probably with straws and other things, but you can see right there that it looks like the stick goes in, and then all of a sudden the stick is in a different location over here, right? It looks like the stick has been broken or bent. That's because of the refraction. Because the wave travels at a different speed through the water than it does through the air. And because it travels at a different speed through the water, the light bends. But it only bends here at the surface. It doesn't bend. It's not like when it gets into the water, it curves as it's traveling through the water. That's not true. When it gets to the water, it bends and it goes in a straight line through the water. And then when it gets back to the air again, then it bends again. All right. So every time your medium changes, the light will bend. Now, if the medium is constantly changing, like for example, temperature is hot and it gets a little cooler, little cooler, little cooler, little cooler, then it's almost as if it's changing mediums again and again and again. And so in that situation, you might be able to get some curve, which we're going to see in the next little video here. But the important thing here is recognizing that refraction happens when the speed of the wave changes. When the speed of the wave changes, it's got to bend. We'll talk more about this specifically when we talk about light later on in this unit, but refraction is a property of waves. All right. Now, I am going to invite you to watch the next video, which was not made by me, but it was very well put together about the bending of sound at night and day, and it answers a couple of questions and makes some interesting connections. But the thing I want you to recognize as you watch it is that that's not purely refraction, because the temperature is always changing. It's talking about something a little bit different there. And sometimes people say, this is refraction. That's not necessarily true. It is going to be bending because of the differences in temperatures, but it's going to be a little less direct than this idea of looking at the stick bending as it goes into the water. All right. So there you go, reflection, refraction, two more properties. We now have 4 properties of waves. All waves do these 4 things: superposition, diffraction, reflection, and refraction. And hopefully those will be things that will help us as we continue to talk about waves, as we continue to talk about sound, and later as we talk about light. All right, see you later.